Ever wondered why there are no elephant-sized spiders or King Kong-sized apes roaming our planet? It's a fascinating question, isn't it? Well, one of the key reasons lies in the unyielding grip of our planet's gravity. You see, when we talk about size, we're really talking about volume, and as an animal grows, its volume increases at a much higher rate than its surface area. This is known as the square cube law. Now, imagine an elephant. Its massive size means it has a lot of weight to support. This weight increases exponentially with size, putting enormous stress on the elephant's skeleton and muscles. Now consider a spider. It's small, so it doesn't have to deal with the same weight issues. But if it was the size of an elephant, its exoskeleton wouldn't be able to support its increased weight. The poor creature would be crushed by its own bulk. So gravity isn't just holding us down, it's also shaping the size and form of every land animal. The bigger the creature, the more gravity pulls, making it more challenging for life to sustain massive bodies. So, it seems the force of gravity plays a massive role in determining the size of land animals, but what else might be at play? Imagine how much food a King Kong-sized ape would need to eat every day to maintain its energy. It's not just about the size of the stomach, but the energy expenditure that comes with it. Just like a car guzzling more gas the faster it goes, larger animals need more food to keep their bodily functions running. Now, consider the blue whale, the largest animal on our planet. It consumes about 4 tons of tiny shrimp-like animals every day. But the blue whale has an advantage. It lives in an environment abundant with its food source. For a land-dwelling creature of similar size, finding enough food becomes a monumental task. The Earth's terrain is vast and varied, but it doesn't offer the same density of food resources as the ocean. A hypothetical King Kong would need an unthinkable amount of food daily, likely much more than the environment could provide. So the energy required to sustain a large body size could be another limiting factor, but there's still more to the story, still more to the... Have you ever thought about how a King Kong-sized ape would actually move? This is where the fascinating field of biomechanics comes into play. Biomechanics is the study of the structure and function of biological systems, such as humans, animals, plants, organs, and cells, by means of the methods of mechanics. Now, imagine the immense weight an animal like King Kong would need to support. As an animal's size increases, its body structure must adapt to bear the increased weight. This means thicker legs, a bulkier body, and more muscle mass. But here's the catch. These changes can limit the animal's mobility and agility. Think about it. A tiny mouse can easily scamper up a tree, but could a colossal creature like King Kong even lift his foot without exerting an enormous amount of energy? And how would he fare in a chase with a predator? Rather poorly, I'd wager. Let's take the example of the dinosaurs. Even though they were massive creatures, dinosaurs were designed with specific adaptations to overcome the biomechanics barrier. Some had long, slender necks to reach food, while others had thick legs and a low center of gravity to support their weight. Yet, even with these adaptations, no dinosaur came close to the size of the blue whale, the largest animal the Earth has ever seen. So, biomechanics presents another challenge to the size of land animals. It's clear that nature has its own ways of keeping things in balance. So, how big can a land animal get? By now, we've explored the 3 key constraints that limit the size of terrestrial creatures: gravity, energy expenditure, and biomechanics. As it turns out, these aren't just theoretical limitations. They're grounded in the realities of our natural world. Gravity, for instance, is like an invisible leash, keeping land animals from ballooning to enormous proportions. It's a constant force, shaping every aspect of our lives and the life forms around us. It's what keeps us grounded, quite literally. And it's also what prevents land-dwelling creatures from reaching the size of giants. Then there's the energy conundrum. The bigger an animal gets, the more energy it needs to sustain itself. This isn't merely a matter of eating more, it's about finding and consuming enough food every single day to fuel a massive body. The sheer effort and resources required to maintain such a large size can outweigh the benefits. And let's not forget biomechanics. The physical structure and function of an animal's body play a crucial role in determining its size. The larger an animal, the more stress is placed on its bones, muscles, and organs. At a certain point, The body simply can't handle the pressure. While humans can imagine creatures of enormous size, these realities of the natural world place practical limits on how big land animals can get. But that doesn't make the natural world any less fascinating. Each creature, big or small, is a marvel of evolution, perfectly adapted to its environment and way of life. While we may not see a real-life King Kong anytime soon, the wonders of nature and the diversity of life on Earth never cease to amaze us. Perhaps we should leave the giant creatures to our imaginations and movie screens.